Okay, so the first question a lot of you, or just one of you, want me to solve is this one. How do we solve this equation? How do we find the values of z in this equation? All right, that is absolutely simple. We want to first try to do the square root method, always. But if we do the square root here, if we apply the square root here and also here, right? What we are left with is a square root with additions and subtractions inside. And if you remember the properties of roots, that is not good. We don't want that. We don't want that. Having an addition and a subtraction inside a root is not good. We cannot apply any type of property or rule to remove those additions, right? And those subtractions. So this is an example of an equation that we cannot solve with the square root method. We can't. Meaning we are going to have to factorize in here. But factorizing this is absolutely simple. All you have to do is open two parentheses. I'm going to also write the equal to 0, which is this part, but I'm just factorizing this part in here, right? I am just carrying the equal to 0 to the other line. And to factorize this, you need to remember how to factorize these types of functions, right? The trick is leave the main value with the root. So the square root of z squared is just z, which means without the exponent. Then leave the first symbol. Since it is positive, you're going to leave it positive here. And then the next one, you're going to do positive by negative. That's negative, so the solution of the next one is negative, right? And now you want to think of two numbers that when you multiply them, the solution is 6. And when you add them, the solution is 1, right? But since one of them is positive and the other is negative, we're talking about subtraction here. We're not talking about addition. We want two numbers that when we multiply them, for example, 6 and 1, 6 by 1 is 6, right? But when we subtract them, the solution has to be 1. So 6 minus 1, this thing is 5. Nah, it doesn't work. These two numbers, 6 and 1, doesn't work, right? How about another two numbers? How about, I don't know, 2 by 3. 2 by 3 is 6, right? And when we subtract them, when we do the subtraction, 2 minus 3 is going to be negative 1. But we want positive 1. No, it doesn't work as well. But that gives you a clue. 2 minus 3, yes, 2 minus 3, that was negative 1. What if you just change the values? What if you just do 3 minus 2? This also is going to give you 6, right? This is also going to give you 6. But if you subtract, this is going to be positive 1. So now we have our two values. One is 3 and the other is 2. But the 2 is the one that goes in the negative. The 2 is the one that goes here because the 2 is the one that is subtracting. Did you see? So now, if we place our results in the board, in the equation, we're going to have positive, that is the 3, and then the negative, which is the 2, right? Let's verify. 3 times negative 2 is negative 6. Correct. Now, 3 minus 2 is positive 1. Correct. We did it perfectly. Now that we factorize, we can open this factorization into two equations that we simplify individually. So the first one is with the first factor, z plus 3. Z plus 3 equals 0. We're going to have z plus 3 equals 0. That is the first equation, right? And then the next one, this line, this is the OR, z minus 2 equals 0, right? Remember, we have a multiplication that is being equal to 0. This is a times b equal 0. So we're going to open it. One is the a equals 0 and one is the b equals 0, right? From here, just solve each equation individually. Z plus 3 equals 0. We want to isolate the z. So z equals -3. And like this, we have our first solution. The first one is -3. Let's work into the second one. Z minus 2 equals 0. All right, the -2 is subtracting because it is negative. So you're going to pass it to the other side to add. You're going to pass it positive. So z equals 2. Here it is, our second solution. Just like that, we have two solutions, and we finished. The two solutions of the equation are -3 and 2. That's it. All right, let me read the chat and see for more questions. Okay. Daniel Felipe Osorio, number 11. Yes, sir. And then Carlos Isaza, profe, could you do the point 15, please? Because I'm not really sure about the result. Sure, buddy. Richie, no entendí en dónde quedó la otra Z. Which Z? Which one, buddy? These are two Z's. I don't know if you can, maybe you can't see them. All right, let's see. Is that better? Is that better? This is the first Z, Z equals -3, and then Z equals 2. Is that better, Richie?
No, in the original equation, in up, the c that is elevated to the power of 1,
Okay.
that, what happened with that c?
Okay, Richie, look. This part, this one over here, right, is what we turn, what we change into our configuration of factors. This part is what we factorize. Okay? This C and this Z are not this one over here. These and these are not this one. These and these are not this Z and this one. No, 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 no. Try to think of it not as, teacher, you just split this Z into these two parts, then what happened with this one? No, don't think about it that way. Don't think about it that way. Think about it as we have two values for Z, two values, because the maximum exponent is two values. That means that the first value is over here and the second value is over there. Try to think about it like that, all right? In these exercises, let me switch into the slides. In these exercises, do you remember this, Richie? Just go back a little bit. Do you remember these exercises? Right? Right. In those exercises, for example, take a look at question 3. W squared minus 8W plus 12, right? In this one, you may say, teacher, there are two W's. If we factorize this, the same is going to happen than the one in the board. It's going to happen the same, right? By factorizing, you're going to split the W's, but it's not like, what did you do with the other W? It's not something like that, all right? It is just the process that you do. Okay? Is that better? Okay, mister, thank you. Okay, all right. Hopefully that works for you, buddy. Okay, so number 11 it is. Let's see, number 11. And then number 15, I think, for Carlos Isaza. Number 11. Okay, number 11 says x squared minus 25 equals 0. X squared minus 25 equals 0. Okay, this is an exercise that can be solved in two ways. This exercise can be solved by doing the square root method or by factorizing. I'm going to show you how to factorize it here, and then over here, I'm going to show you the square root method. All right. By factorizing, what you need to do is recognize that here you have a difference That is why the minus is there, because it is a difference of squares. This is a square because it's elevated to the 2. That is a square, right? And then 25 is also a square. It's a square because it is 5 square, right? 5 to the 2. So this is also a square. To factorize a difference of squares, what you need to do is do the first square, but without the exponent, so the number alone, x, plus the other number alone without the square, so 5. Remember, 25 can be seen as 5 square, right? This 25 can be seen as 5 square. So what you want to do is put the roots of two solutions, the roots of the two numbers. The root of x squared is x, and the root of 25 is 5, right? Put it positive. And then x minus 5. The same value, the same x, and the same value, the same 5. But one is positive and the other is negative. This is how you factorize a difference of squares. Since the main equation was equal to 0, here we have it equal to 0 as well. And just like in the other exercise, now that we have a factorization equal to 0, we can split the two factorizations into two equations. The first one, x plus 5 equal to 0. And the second one, x minus 5 equal to 0. Isolate each individually. Here, the first solution is x equals negative 5. The second solution is x equals positive 5. Remember, the positive 5 passes to subtract. The negative 5 passes as positive. So one solution and the other solution. Just like that is how you will solve this exercise by factorizing. But you can also do it with this square root method. Here it is. Let me write it again. X squared minus 25 equals 0, right? How would you do this one by using the square root method? Absolutely simple. Instead of doing the square root here, because again, you would have a negative inside of a root, and that is not good. We don't want that. What if we take the negative away? What if we pass the negative 25 to the other side? Look at this. X squared is going to be equal to positive 25. It was negative, so you're going to pass it positive. And now, if we apply the square root here and here, there's no negative in here. There's no positive, no negative, no nothing. We can cancel the exponent with the root just like that. The solution is going to be x equals the square root of 25. But the square root of 25 is both positive 5 and negative 5. So positive or negative 5, right? Since we have positive and negative, that means our x can take two values. Either the first value, positive x, or the second value, negative x, equal to negative 5. Positive 5 or negative 5, sorry. So here, our two solutions. Look at this. Positive 5 is the same than here, positive 5. And then negative 5 is the same than here, right? We have positive and negative. Which process do you choose to do? That is up to you. Me, personally, I would do this one. I would do the difference of squares, right? I would do this one. Why? In all honesty, I don't know. I think I prefer this one better, but I don't know. Why wouldn't I do this one? I don't know. This one is perfect as well. It is up to you which one you want, all right? Danny, hopefully this was good for you. Let's jump into the next question.
Thanks, teacher.
No problem, buddy. Point 15 from Carlos Daniel Izaza. Luna Karina. Análisis. Mister, ¿puedes hacer el análisis 17? La pregunta 17. Yes. Luna, I'll do it in a minute, all right? Laura Valentina, profe, la 17, porfa. Marino, profe, la 15, porfa. Okay, then 23, 19, 27. All right, guys, you guys are fast. All right. Let me do number 15, okay. Then I think it was 17, then 19, and we will work our way up, okay. So which one was it? 15, 15. Let me erase all of these, and we'll do number 15 now. You know what? Let me stop the recording here, and once I have it in the board, we will continue.